Hi guys, we're back for more on soil erosion. This time we're going to kind of talk about some of the impacts of soil erosion in a little bit more in detail. So, share my screen again. Okay, so we already know that erosion is this removal of soil, this movement of soil off-site. We know it's being accelerated by different kinds of landscape management practices that expose soil. We know when soil is exposed and it's being hit by raindrops that are breaking apart soil aggregates, or we're doing other landscape management practices that are breaking down soil aggregates, blocking up macropores, that we're limiting drainage, and then we're leading to more surface flow, surface water movement, which leads to more erosion. So we know all that already, but now we're going to kind of think about what the impacts might be. So first of all, let's think about the on-site effects. So what happens at the site that the soil is being removed from that is undesirable? Well, first of all, you're just removing your soil. So if you have an interest in the soil being there, like if you're trying to farm there, for example, then that's not desirable. And in particular, the soil that's being removed, the surface soil or the top soil, the A-horizon soil, is usually the most valuable layer of the soil, right? That's the soil that has the most organic matter in it. And that's the soil that's really going to be supporting plant root growth and fungal growth. And that's where you're going to be pulling lots of nutrients from to grow your plants. And so if that's a soil that you're removing, then you're really going to be undermining the productivity of any soil that you have left. And God forbid, you might actually be at some point removing all your soil down to like bedrock, in which you're really not going to be able to, of course, grow food there anymore. So it tends to not only remove the surface A-horizon first, but even more than that, it tends to remove fine soil fragments and organic matter, which is pretty light and fluffy. If you remember when we did our jar test and we shook up the soil, the stuff that came on top, there was like organic matter that kind of floated on the surface of the water, and then like clay and silt layers on the top. So those are the layers that have organic nutrients in them. And then remember, the clay portion of the soil is really good at holding water and holding nutrients. So if we're removing all that material, then we're leaving behind a much less kind of active and nutritious soil in its wake. Another thing that we mentioned already is that what's left behind after the soil removal process occurs is a pretty crusted surface soil where there's not a lot of nice aggregates, but instead there's this almost like cemented layer of all these fine particles that have been broken down through exposure to raindrops. And so that dispersion of all these fine soil particles across the surface is not only in that particular event, but now also in the future going to limit infiltration of water, which limits ultimate water storage, and then kind of sets up poor conditions for future potential erosion. Another thing that can happen is that a lot of salts that dissolve easily in water can start to dissolve across the surface, and then they can be moved, and then they can kind of like crust across the surface as the water dries. And so we can leave this salty residue behind, which is undesirable as well. And we'll talk more about that later. But basically, lots of salts kind of inhibit water uptake by plants. It's one of the reasons why we don't like salts in the soil. And then, of course, whether you're planting seeds intentionally or there's just like a native seed bank in the soil, you may be also removing a lot of your seeds that could be serving to kind of repopulate that landscape with vegetation that would help protect the soil and the surface. So as you're removing the soil, you might be removing these other valuable organisms or parts of organisms as well. So you're leaving behind a degraded soil or erosion site. So those are the on-site impacts. Downstream impacts or off-site impacts, right, where the material moves to, are varied, but one concern is about water quality downstream. So there's something that's called eutrophication, and eutrophication happens when there's a big pulse of a lot of nutrients that get washed into the water, and the nutrients in the water can lead to big balloons of algae that grow really quickly in the water. And if there's a little bit of algae growing in the water, that can be a good thing. It can be a food source for aquatic organisms. But when there's lots and lots of algae that grows very quickly in response to this big pulse of nutrients, then there's also a big bloom of bacteria that grow to feed on the algae and break down the dying and decomposing algae. And that bacteria can suck up lots of the oxygen in the water. And so there can be big crashes in the oxygen concentration in the water, which can then lead to lots of death of aquatic organisms like fish or other macroinvertebrates, insects, little minnows, frogs, etc. And then there's even more bacteria that are feeding on those as they're dying, and it leads to some pretty kind of nasty water conditions and lots of death to aquatic organisms. So that's happening as lots of maybe just natural organic matter is being washed across the surface, but then it certainly is accelerated when we have soil from agricultural landscapes that has lots of phosphorus or nitrogen based, like nitrate and phosphate fertilizer that's being washed into the waterways. We can get these really bad water conditions. Other things that can get washed into the soil are like toxic metals. And then also, even if we didn't have any of this algae bloom or any of things that were themselves necessarily toxic, just all this extra sediment can get into the water and make it very turbid, or we refer to turbidity as just like cloudiness in the water. And that cloudiness in the water from all the loose sediment can be problematic for aquatic vegetation. It can be problematic for fish and like things with gills, or certainly where fish may be trying to spawn in the water. If there's lots of fine sediment that gets into all these like cobbles, lots of native like salmonoid type fishes in particular, and other types of fishes are not able to spawn in the gravel as in the way that they would naturally be able to do in the water. So that's undesirable. Obviously, if lots of water is flowing across the surface at once, it can lead to flooding. So that's not desirable. And then also all the sediment can lead to infill in things like big reservoirs. And that's not desirable because we've built these reservoirs to store water, not to store sediment. And if we have them mostly filled up with sediment instead of water, then we're reducing the amount of water that we have to use later, which is of course one of the purposes of reservoirs. Or if it's a big hydropower dam, we're going to be minimizing the amount of energy that we can make, and removing sediments from behind these dams is a very, very expensive project. So lots of organizations that have dams, groups like PG&E, big companies like PG&E, have actually invested a lot of money in upstream soil erosion mitigation projects because it's cheaper for them to fund these kind of erosion mitigation projects in places like Plumas County rather than digging, like draining reservoirs and digging up soil from the reservoir. So it's kind of an illustration of the real economic interest in keeping soil on site. Other offsite impacts that might have to do with more like wind-blown sediments could be kind of the smothering of plants, filling in of drainage networks, and of course, health hazards. You know, there's lots of potential like asthma conditions or pneumonial type conditions, valley fever, if you know about that. It's kind of unfortunately sort of common like pneumonia-like thing that happens to lots of people that live in the Central Valley. My husband grew up in Bakersfield, so he talks a lot about that. And so anyway, we don't really benefit from having all this sediment and any chemicals that are contained in that sediment, like nitrates, phosphates, copper, like whatever we're putting on our soil in our lungs. That's not the place that we intended that material to be. And so we don't want it there. It's not good for us. So kind of one of the most extreme examples we know of a massive erosional crisis in our country is the Dust Bowl. So probably anyone who grew up in the United States has learned something about the Dust Bowl throughout their education. And as you may or may not remember, it took place in the 1930s. It kind of overlapped with the period of the Great Depression, which made the whole thing much more severe. But it was about a 7-year-long drought that hit the Southern Plains area. So places like Arkansas and Oklahoma, northern Texas, Colorado, et cetera. And it was actually not a super severe drought, but there was really severe impacts to the people that were living in that environment because of some unfortunate landscape management practices that had been occurring in the decades leading up to this drought. Because of poor management decisions where they had extensively plowed up kind of the short grass native prairie there that had been previously used, of course, just to support natural ecosystems, and had also previously been used a lot to as rangeland for cattle in particular, because it had kind of previously been thought to be too dry to support agriculture. There was this big boom in the wheat industry where there was a lot of high value placed on wheat, especially after World War I. And so people really aggressively came into this landscape that had been kind of overlooked as intensive agricultural land, and they plowed it up very, very rapidly. And then there was a kind of a particularly wet period, unusually wet, rainy period that occurred in the 1920s. And so people that did this were able to make money growing wheat for a certain amount of time, for about a decade. And then when it returned to a more average rainfall, and then kind of cycled back into a drought, and again, not a major drought, sort of a minor drought, all of a sudden there wasn't enough water to support the wheat, and there was just expansive areas that had been plowed up, and there was an enormous amount of wind-blown erosion that was moving around, and of course having really devastating impacts to the people that were trying to survive there, feed their families, keep their property, etc. And so this is considered by many people to be the worst sustained environmental crisis in the United States history. And this is a picture of farms with this big duster, as they were sometimes called, this dust storm blowing in to this neighborhood here. So as I already mentioned, there had been extensive tilling in the decade leading up to the Dust Bowl, and it removed prairie and land that had been previously considered unsuitable for agriculture due to relatively low rainfall, less than about 20 inches a year. So that's about half the rainfall that we get in Quincy. And then around the same time, there was pretty rapid mechanization of a lot of agricultural technology. Things like tractors and combine harvesters allowed people to remove native vegetation to try to put in intensive agricultural fields and things like wheat much more quickly than they had in the past. And then at this time, they weren't using a lot of best management practices that are encouraged today, like cover crops or having trees for windbreaks, et cetera. And so, as I kind of already said, there was this crisis of this enormous amount of tilled landscape that wasn't receiving enough water to either regrow native prairie or to support the wheat or other crops. And so all this exposed landscape was being blown across the Southern Plains region, creating lots of economic, environmental, and kind of personal and health devastation. Okay, that's enough about that. Of course, that's a big topic, but I actually have some video clips I'm going to have you guys watch about the Dust Bowl.